let's go back to this next one. So this one is a slightly different scenario because if you look, the degrees on the top and the bottom aren't the same. The degree is the power on the top and bottom. So when the power on the bottom is bigger than the one on the top, this is our next scenario or our next type. So the degree on the bottom is greater than the degree of the top. Remember, degree is the exponent. When we do that, it's actually really easy to figure out where the asymptote is. It's automatically going to be at 0 for the y. So the y is going to be equal 0 for the horizontal. Oops, I abbreviated a couple of times there. So this must be y equals 0. And that's always going to be the case when the degree on the bottom is bigger than the degree on the top. So again, we're going to draw that asymptote then. The horizontal asymptote across the middle this time. So there's an asymptote there. Remember how we find the vertical asymptote? That's always the same. How do we find that? Look at the one right above it. How do we find the vertical? What's that? So the bottom equal to 0. So that never changes. It just, obviously the value will change. So x squared minus 4 equals 0. Want to solve that as square roots? Move the 4 over, take the square root, don't forget positive and negative though. Plus and minus 2. So this one has 2 asymptotes. So that's that scenario where it can have 2 asymptotes. Positive and negative 2. That means there actually can be 3 sections of this graph. So, because now there's 6 sections of fencing. There's upper, lower, middle, up, there's these 3 dividing sections that we can end up having the graph to be in. So again, I like those asymptotes or the intercepts to help me. So the x-intercept is where y equals 0. So that's where I'm going to set the top equal to 0. First point. Wait. Is that right? Doesn't really make sense. That's on the line. Did I do something wrong?
I don't know. This is really solid.
No. Denominator is greater than. I'm going to check it with graph. Sorry. We're going to pause for a second.
What did you say?
I saw it 60. That's why you do Greek stuff, like she's like a geofraction learner. What? So it's like
I was not here tomorrow.
over average. 75 hours.
Because our point is on an asymptote. I can't figure out why that would be. So I'm going to pick a point just to kind of try to figure out the rest of this. We have to basically pick points in like all three like sections. So I have to pick a point on like this side, in the middle, and then on this side. So the 4 isn't really that helpful because it's on that asymptote. And I think this is just a weird example, and I probably should have pulled this one out. So I'm going to check 3, so x equals 3. So that's in between the asymptote and the 4, just to figure out what's going on here. So we're going to do 2 times 3 minus 8 over 3 squared minus 4. So this is negative 2 over 5. So it's a negative 2/5, so it's down here. So I think what's happening here is that the fence is here, but we got to stay like right on that line, I think. So we're down in this quadrant here. I'm thinking this is kind of a special case where somehow it like gets to go around that, but I guess it's just a bad example. So the 1 is down over there. We're going to pick one this way. So I'm going to check negative 3 on this side of the line. So negative 3, this ends up being negative 14 over 5. So negative like 2 point something. So again, this one's going to be down in this quadrant. But then I have to figure out the middle. And I showed you guys one before like this, where it's kind of like a parabola in the middle, and we just have to figure out what that looks like. So the y-intercept is probably going to help us with that. I should have done that one already. So x equals 0, I put 0 in. Negative 8 over negative 4, so 2. So I'm just going to do like a parabola there in the middle. And again, this doesn't have to be exactly perfect. Like you might say like your parabola is a little too steep, or it should be like fatter at the bottom. Like I don't need that precise of just kind of get that U shape down. If you want to pick more points, you're always welcome to. The biggest thing is trying to notice where that horizontal asymptote is depending on the situation. So far we talked about the degrees being equal, the degree of the bottom being bigger, and then obviously the other one is the degree of the top being bigger. So when the degree is the top being bigger, there's no horizontal asymptote. It's called a slant asymptote instead. So we're not going to do ones like these. This is like maybe like a pre-calc level type problem. So when the degree on the top or the degree on the bottom is smaller than the degree on the top, then we have what we have a slant asymptote. So we're not going to do these. So this is just trying to show you like the other option, but we're not going to get any like that. So that means the asymptote is actually like kind of slanted in the problem. We will not do ones like that. If you look in your book, they'll have them, but we don't need to worry about them. So what you guys have listed here, and I actually did the homework already to make sure it made sense and that it was doable and there weren't any weird slant ones showing up in there. So the homework is listed there for you guys, and then there should be enough graphs for you to be able to do all the graphs right away too.
Sweet.
But I'd suggest doing these like 4 quadrants with the vertical, horizontal, x and y intercepts.